All right, so we just finished this example. Next, we have a think, pair, share. Now, again, generally, with my lecture notes, the think, pair, shares, I don't normally put calculator screenshots, but here you're at the early stages of learning about normal distributions and using calculator functions to calculate areas. So I've included those, here. Um, so let's look at this example. Um, so what you can do at this point, if you want, is just pause the video and then resume and see my solution to this think, pair, share. But certainly you lose nothing by giving it a try first. Maybe just use pencil in case you need to erase. Okay, so in one day, the ages of all patients who checked in were recorded. Age was normally distributed with a mean of 52 and a standard deviation of 12. Part A is find the probability that a randomly selected patient was between 60 and 69 years old. All right. So again, it helps to maybe just start with what you're given. So let's see here. We're talking about ages of patients. Age was normally distributed. So age is our random variable, and it is normally distributed with a mean of 52 and a standard deviation of 12. Okay, let me write that a little bit better. All right. So let me go ahead and write that down. So we've got a normal distribution with a mean of 52 and a standard deviation of 12. Now, find the probability that a randomly selected patient was between 60 and 69. Well, let's get some idea of where 60 and 69 is going to be. Let's go ahead and draw what we've got here. So 60 and 69 is going to be greater than 52. Younger. Okay, so we should probably go ahead and I'm just trying to think ahead, but that's slowing me down. All right, let me just go ahead and just start drawing. All right, so we've got a normal distribution that should be somewhat bell-shaped and symmetrical. Not too bad. With a mean of 52, which is the center of the normal distribution, and we've got standard deviations of 12. So we're going to add 12. All right, so if we add 12, we're going to get 64. Add 12 again, we're going to get 76. All right, that'll work. And let me go 12 the other direction too, just to maybe challenge my subtraction skills here. And if we subtract 12 again, is that going to be, yeah, 28. All right. Now, let's see where we stand on this. So find the probability that a randomly selected patient has an age between 60 and 69. All right, so actually I need to put that X in a different place. So between 60 and 69. So it's going to be less than 69, but greater than 60. All right, so 60 is going to be somewhere right about here. And 69 is going to be somewhere right about there. So actually, we want the area between those two values, right? Between 60 and 69. All right. Well, what do we expect? Okay, it's a little harder to deduce an expectation here, but at first glance, I would say that the probability that we're calculating is going to be less than half. And that's something. right? Because a probability of 1/2 would be the probability to one side of the mean. And so this red shaded area is certainly less than that. I kind of made that to proportion. Gosh, I could maybe even say that it's going to be less than 25%. This is a little bit of a dangerous expectation here because it just depends on how accurately I drew it. But certainly this one seems pretty valid. All right, well, let's go ahead and punch this into our calculator and see what the area is between 60 and 69. And that'll tell us our probability. So Texas Instruments, our lower bound is going to be 60, upper bound is 69, with a mean of 52 and a standard deviation of 12. NumWorks, we want this option because we want the area in between two values with a mean of 52, standard deviation of 12, and that's going to be between 60 and 69. And when you punch that in, that should be 0.1742 or 17.42%. All right, how does that fit with our expectations? Well, I expected it to be less than half. And certainly this is less than half. So that's good. And I went a little stretch further and said that it was less than 25%. And, it is. So I kind of got lucky there. But not a bad sketch and evaluation. Okay. All right, let's look at the next one. So find the probability that a randomly selected patient was 24 years old or younger. Okay. So let's just redraw our distribution to kind of see where we stand with this problem. And just think of this as art. You're doing art in a math class. That's fun. Okay, let's see here. 64, 76, 40, 28. All right, so 24 actually is going to be right here to the left of 28. And so find the probability that a randomly selected patient is 24 years old or younger. So less than or equal to 24. So we want this area right there. All right. Well, certainly we can expect this probability to be less than a half, right? And because this is beyond two standard deviations here, I'm going to venture to say that this is going to be even less than 5%. So why am I saying that? The reason why I'm saying that again is I'm pointing towards the empirical rule. I could probably go even smaller. So the empirical rule says that between two standard deviations from the mean, this area here is 0.9544. So if that area is 0.9544, it's not exact, but just for mental math, I'm just going to say 95%. Okay, that's close enough. Then that means that outside this area is about 5%, which means that this tail here has an area of about 2.5%. And this area out here has an area of, let's see, I'm running out of room. Could have given myself more room here. This area out here is also going to be 2.5%. So I'm going to venture to say that the area I'm going to calculate is less than 2.5%. I think I can say that with some confidence here. Let's see if I'm right. So on the Texas Instruments calculator, the lower bound is going to be negative infinity. So we want to put negative E99 with an upper bound of 24. And that has a mean of 52 and a standard deviation of 12. And with the NumWorks calculator, okay, mean of 52, standard deviation of 12, with an area to the left. So values of x that are less than 24. And what this should come out to is 0.0098, which is 0.98%. So does this calculated result match our expectations? Well, I expected it to be less than 0.025. And this value is less than 0.025. So my answer really does fit my expectations. So that gives me a lot of confidence that I answered this question correctly. And you'll notice that, I'm trying to map out what my expectations are for my answer. I did it for this thing pair share, and I did it in the previous example, right? I started talking about expectations. It's really handy to critically think about your expectations before you calculate an answer, because when you're working on an exam or a quiz, you've only got one chance to get it right. And if you give it just a little bit of thought, you can give yourself some reassurance that the answer you calculated is right on an exam. If you calculate something and it doesn't fit your expectations, then look at your calculation. Maybe your calculation is wrong, or maybe reevaluate your expectations. But you know, um, it's going to be more common that you made some simple algebraic error somewhere and you missed a negative, or you didn't add a value, or you multiplied wrong. You made some kind of small algebraic error, and it's hard to see those small algebraic errors. So it helps having this self-check to check your answer against what your expectation was when you first started out. All right, and that's a common thing I try to do, is I try to get you guys to think critically about the bounds for your error, or for the bounds for your answer, the constraints around your answer, um, before you actually calculate it. All right, let me know if you have any questions.